Hello everyone again, and welcome to the Dijo Merit's DM Science Institute channel, and truly a pleasure to actually have you on this particular space. In this particular video here, we're going to be focusing on a specific type of reaction that has an interesting features that actually plays a huge role in the makeup of this particular reaction, which involves coupling to Alkyne. And this reaction here was actually done by Sonogashira, and this reaction in this case is called a Sonogashira reaction, and there are key themes to keep in mind in these reactions, and these key themes are three. First, you need to understand that under palladium catalyst coupling, the terminal alkynes with our Aryl or violin halide is actually crucial for this reaction to actually take place. And the next one here is that this reaction actually require palladium 0 catalyst complex in the presence of a base using copper 1 iodide. Take note of that. And the base in this case that is going to be used is usually an amine, and this amine is going to be crucial in the specific side reaction step that will later be incorporated into the cyclic reaction. And our particular copper 1 iodide is actually acting as a co-catalyst, which actually is involved in one of the reactions that we're going to talk about very soon in terms of the mechanisms. And finally here is that the alkyne actually needs no metal to activate it. So those are the three things to actually keep in mind for this particular reaction to take place. And we're going to move on to the overall reaction, where all these reactants will actually come into play and look at the conditions in detail and look at the substrates getting to the products. And we're going to focus on first the overall reaction. The overall reaction step is involving our Aryl halide, and this will be done in the presence of terminal alkyne. And this reaction here, which involves the substrates, will be done under the presence of our palladium 0 catalyst, and our co-catalyst in this case is going to be copper 1 iodide, and this will be done in the presence of a really interesting base, which is in this case is going to be a diethylamine, and then this will be done under mild conditions at room temperature, usually 25 degrees Celsius, and around 3 to 6 hours for this reaction to actually take place and lead to the formation of our desired products, where we have our specific Aryl slash Alkyne, and this will have our specific triple bond present in there in the middle, which leads to our coupled products, and we have our other product in the mix in there that we don't really care about. So we're going to look at the main mechanism for this particular overall reaction, and the mechanism actually going to begin with our specific palladium 0, which in this case is going to be palladium tetraphosphine, and this palladium 0 will be subjected to our specific Aryl halide, which is actually going to be performing a reaction called oxidative addition, where our palladium complex 0 will generate or will lead to the formation of palladium 2. And this palladium 2 actually will have our complex, which has 2 phosphines out, and introduces our Aryl and halide forming bond with palladium. So therefore, in this case, this particular complex intermediate palladium 2 will be ready for the next reaction step. Now, the other side reaction that will be incorporated into this particular palladium 2 intermediate is our base. In this case is going to be diethylamine, and this reaction here, where our nitrogen segments will actually perform deprotonation, where it picks up the hydrogen, and then the hydrogen carbon actually becomes a lone pair on the carbon. Therefore, the carbon actually has a negative charge with a lone pair and this particular part of the carbon will actually interact ionically with our copper, and this copper here, which is copper 1 plus, is going to be influential in integrating our specific carbon anionic segment of our Alkyne to the specific palladium to intermediate. As a result, we actually have a form of an SN2 reaction, where our SN2 reaction leads to the lone pair becoming a bonding pair with our palladium, and then we have a good leaving group, which is our halide. And this actually is our transmetallation step that actually leads to the formation of a palladium carbon bond with our specific triple bonded substrate on one side, and we have our Aryl on the other side of the palladium. Therefore, our reductive elimination actually leads to the coupling of our two organic ligands that are going to be formed, and this coupled product actually then regenerates our specific palladium 0 from palladium 2. So that is the overall cyclic mechanism for this particular reaction, which is the Sonogashira reaction, and the key step here is involving the copper forming a particular intermediate with an alkynyl form in this particular step right there. That is a key thing to keep in mind. And we have other side products we don't really care about. In this case, it's going to be copper with our halide, ions with our other amine segments, which we don't really care too much about. And that is it for our specific cyclic reaction step. So what are the considerations to keep in mind for this particular reaction, which involves our Sonogashira reaction? So first is that using a stable and soluble palladium 2 derivative, in this case bis-triphenylphosphine palladium 2 chloride instead of palladium 0, we actually give a coordinatively unsaturated catalytically active palladium 0 species. So this leads to the second condition or consideration, which is that geometry of our alkene is generally preserved so that the CZ and the trans E dichloroethylene actually gave the two different geometrically isomers of the enil. So therefore, in this particular step here, when we have our Z dichloroethylene and our E dichloroethylene actually subject to the same conditions, where we have our specific alkyne in the presence of palladium trisphosphine. Our co-catalyst in this case is copper 1 iodide, and we have our butyl amine, which is the base at room temperature 25 degrees Celsius, and the time spent is around 5 hours. We actually generate on one side of the reaction, which involves the Z reactant or substrate, we actually have a 95% yield of our specific Z enil, while on the other side we actually have an increase in the yield to 98% yield of our E form of our enil product. Therefore, this shows an excellent yield and also a really high stereochemical purity for our target products. This is really fascinating to see this play out involving the Sonogashira reaction, and how this actually is important in the coupling of alkyne. In these particular steps right here, you need to take note that under tetra conditions at room temperature, the reaction can be used with thermally sensitive substrates, which is the key conditions to keep in mind. Our oxidative addition of our organic halide gives our palladium 2 intermediate, and then our transmetallation with our alkynyl copper actually then leads to the formation of our intermediate through transmetallation, and then our final step, which is reductive elimination, generates our coupling of our two organic ligands, which are the key terms to keep in mind in this particular reaction in here. So thanks for following me through this, truly appreciate it. Please hit a comment down below, let me hear your thought about this Sonogashira reaction. And on our next video, we're going to look at palladium catalyzed ammoniation of aromatic rings, and this will be crucial in looking at how this is going to be critical in a different type of catalytic reaction, which involves the Buchwald and Hartwig reactions. So thanks for following me through this, truly appreciate it. Hit a comment down below, let me hear your thoughts, and please don't forget to subscribe, by that way others and you will actually get up to date on the videos coming up soon. And see you all on the next one. Stay smart as always and believe in yourselves.